Right. Thank you, Tim. Again, my name is Mike. I'm from Zentera Systems. I appreciate the opportunity to come here and speak with you. I'm going to do something a little bit different today. I know that there's an RFI as a sample to go through. I have provided a response to it. You can read it. I don't want to go through it with you because I think, if you're really that interested, you can read it. And if there's questions on it, you can ask me about what we do and how it's different. So today I decided I'm going to talk about practical considerations for adopting zero trust security and use the time that way. Hopefully that's okay with everybody. And I think that one of the things that I want to start with is just commenting on one concept that's been with us for a long time, which is network security. That is in itself a very funny word. If you think about it, network security means that security is being done in the network. And if you think about it a little bit deeper, that's actually fairly unfair to our friends in networking who are doing a very good job of making things fast. They make things low latency. They make things very reliable and resilient. But if you ask them also to make them secure, then you're asking for trouble because now you've just made everything coupled and dumped on them. And I think that if you look at some of the things like NIST 800-207, I mean, we've seen it in some of the discussions and the talks yesterday, today. There are things like discussions of implicit trust zones. There's discussions of secure enclaves, and if you expect the network people to come in and do that for you and somehow help you out by making these things disconnected or decoupled, then you are putting barriers in front of zero trust adoption that are going to be problematic in the long run. Okay, so that our approach to zero trust and to security in general is at Zentera is that we believe that networking and security, as much as possible, need to be decoupled. And as a vendor and as a security provider, we need to do things in a way that allows the networking to stay the way it is, the application to stay the way it is, but to layer application security and network security on top of it in a way that we just don't mess all these things together. Okay, so that's where we come from. And so as a vendor, we've been around for 10 years. We've been shipping products since 2014. We actually started not calling it zero trust, but we've been doing the same thing since then. So we've been building out our solution over the years, just making it bigger and bigger and covering more cases and things like that. So let me go through and talk about how I'm going to use today's time. So I'm going to talk about first zero trust confusion, and I apologize in advance because I'm going to go and redefine zero trust again, which is what everybody has done. And by this point, you're probably like, Mike, please stop. I've heard enough about it, but I'm sorry, I have to do it again. And so there's reasons for it, and I'll explain. And then we're going to check our definitions, and then we can go through, explanation of our zero trust fabric. What does it mean? Why do I call it a fabric? How does it work? How does it apply to the SEI RFI? So I'm going to do this at a high level, just a 1,000-foot level, and then details go through the RFI response. So you can see that. And then finally, I'm going to get down into some of the operational pitfalls that we've run into. We've seen people who are thinking about this area. Where do they get stuck? What is it that keeps them from moving forward in their journey towards zero trust? I don't think you will find anyone that says, no, I don't want zero trust. Of course, everybody wants it, but then it's all the details, right? All those things that get in the way. Okay, so starting with the zero trust definition, and I apologize again, I'm going to talk about it, but I think that this confusion about what it is and what it means leads to some of the pitfalls that I'm going to talk about later. And so I completely agree, Greg, with your definition that zero trust is a strategy. And what I'm going to say is very much, I don't think I'm going to offend Chase if he's around the corner there somewhere. I can't see him, but or John. Or anyone else, because I'm very much following Forrester's definition, in terms of what it is that zero trust is. And so I'm going to start, with this statement. It is a security model where authentication and authorization are approve every single network connection. And all unauthenticated, unauthorized connections are not approved. They're blocked by default. Okay, so this is how I think David Holmes in his most recent paper kind of described it. You have to start by blocking all connections that are on the shared network, and that's a cloaking function. You basically take something and you hide it by blocking everything that could otherwise talk to it. Then you have to re-authenticate. Who are the users, the devices, the applications? Applications is also a loose word. People mean different things when they talk about applications. What I mean by applications, I mean software processes. So the actual process, the SSH process, that, to me, that's an application. You might bundle a bunch of those together into one application, which might be a web application, but then to me, that I break that down mentally into, okay, there's an Apache server, there's a Tomcat server, there's a MySQL server. Those are three different things that are all, distinct. But to me, I'm focusing on the lower level because that's where I care about. How do I control the access between those things? Okay. Then, based on the identity of those things and the policy, which is the authentication, the authorization that we just heard about. I'm going to go and re-enable access, okay, so that I get to do what I want to do, okay, and then I'm going to continuously monitor. So I think I've kept it pretty faithful to David's paper. So I'm trying not to go too far off the reservation, except there are some expanded requirements that you have to think about if you're trying to deal with something like M2209. Where there are things like, LAN encryption, encrypted DNS, attribute-based access control that you want to add and layer on top of it. So those are kind of like bonus points, that are over and above the core Zero Trust. So this to me, the first four are central to achieving that strategy. And the reason why I have to do this is because, if you don't define what you mean by I've implemented Zero Trust, then it's very difficult to look at various solutions and approaches and say, okay, well, is this actually achieving it? What is your framework by which you rate or decide that you actually achieve Zero Trust? Okay, as a strategy. So let's play a game. Okay, and I hope I don't offend too many people. I see no tomatoes in the room, so can't throw them at me, but there are other things you could throw. So let's find out how good your aim is. I call this Zero Trust or not Zero Trust. Zero Trust being a strategy. Maybe it should be, does this actually achieve Zero Trust or does it not? But as a logo, it doesn't really work well to me, to call it that. So first of all, starting 10 points. Which of the following completely enforces Zero Trust? This is a gimme, right? VPN, firewalls, VLANs, even cloud VPCs. Cloud VPC is just another network that's implemented software somewhere else, or none of the above. Okay, well, that's, I think, easy, none of the above. There's no concept of user, device, application identity. I have no authentication, no authorization involved in that. It's basically just based on IP addresses. Okay. So second question, which of these enforces Zero Trust? Again, a little bit harder because they're involved with Zero Trust somehow, but these are not technically Zero Trust. You need an IAM solution, you need a PAM, you need some SSO to make things easy for users, but these are not in and of themselves, going to give you what you need. Okay, now here's the hard question. Which of these enforces Zero Trust? ZTNA, microsegmentation, none of the above. It depends. ZTNA has Zero Trust in the name. So anyone? Okay, I'm going to go with it depends. Okay, because each vendor has their own implementation of exactly what it is. What's Zero Trust? What's ZTNA? What's microsegmentation? Now let me explain. ZTNA, can be implemented in a number of ways. If you implement it as a gateway, then you have that implicit trust zone, right? So you have this question of, okay, now I've got remote access covered. When I come on-prem, am I able to, perform the same level of enforcement, and how do I do that for the on-prem users? And there was a comment yesterday about turning your Wi-Fi into a guest Wi-Fi, which is, I think, great and something that you should do. But then how do you prevent somebody from plugging a network jack in and getting on the network that way? Whether they mean to or not, they plug a cable into the wall and say, oh, let me see that if that works, and I got access. So basically, what you've done with the gateway model is you've punted that problem off to the network people and said, okay, you go figure out how to keep everybody off this network, then my gateway can be zero trust. Right? So that's what I mean by it depends. You have to look really carefully at what you're doing. Second is microsegmentation. So microsegmentation, I think that word is abused because I think, as Christopher pointed out yesterday, there are many connotations. When you talk to customers about microsegmentation, they think of SDN, they think of ACI or NSX, they think of solutions like that. So it's very unclear, in the customer's mind, or in when you use that term, what exactly you mean. So you have to dig into, does it actually look at and take care of the identity? And I think Illumio, for example, and Guardicore also, they use the term zero trust segmentation. I know that's starting to become more popular as a way to differentiate from some of the confusion that's out there. So that's why I say, okay, it depends. And last. What happens if I start combining technologies together? I start taking things that are zero trust, maybe they're zero trust, and then I stop. I put a mess together of different technologies, a gateway and a VLAN, maybe a web application plus some IAM. I'm going to say I don't think that any of those are zero trust, because they haven't really gone and taken full responsibility for those four core pieces, denying access by default, and then going through and re-enabling access based on authentication, authorization, and continuously monitoring. Okay, so I'm going to say no. So what do we do, and why do I call it a zero trust fabric? Okay, so our approach is that we want to take responsibility for all those things. So we're going to create a default deny and be able to enable access to whatever somebody's supposed to have access to. Okay, so our model is our product is called CoIP. CoIP stands for Cloud over IP. I get that all the time because when I said we started in 2014, 2012, and voice over IP was popular at the time. It's still popular, but you don't hear that much about it anymore because everybody expects it. But so anyway, that's where the name comes from. It's supposed to be cloud over IP, but the idea, the concept, has stuck, and we've continued with it. Basically, we deploy software agents that are on each of the servers that you care about, application servers, user machines. There's client, light client models that are like Microsoft Teams or Zoom. And get you the ability to not only control the access, but also to check the security posture of the device before you grant that access. So once you've installed and onboarded those applications, you create a micro perimeter around it, which we call application chamber in our concept. The application chamber is a segmentation, it's zero trust. It does block access off the network by default, depending on how you set it up. But the idea is that we want to, again, decouple the network from the application from the security so that you can deploy this, then turn it on later without breaking anything in the application, test it so that you could revert back to a known working state if you broke something. Okay. The zero trust authentication and authorization is performed at the application. So you can think of this as different ways of inserting the security. So we want to insert the security in line with the application, as close as possible to the application, so that we don't mess with the network as much as possible. And that way we've blocked lateral access inside, we've blocked the access from remote, we've got all different paths that are taken care of. Which I think is pretty complete in terms of the different ways to think about it. Okay, so again, it's software defined. We don't have to get detailed support from the networking teams to be able to do what we need to do. It is overlay, so not trying to change the application or ask people to rewrite what they're doing. and consistent. So any environment, any application that's running in the cloud, in on-prem environments, in VMware, NSX, Nutanix. Those kinds of environments, it doesn't matter, OpenStack, you just go ahead and because you're doing this the software level and not coupled in to whatever infrastructure is there. Okay, so how it works. We have a control plane, data plane split. We have an orchestrator, which is, you can think of that as our policy decision point, where all the policies and all the identities of things are kind of known. We connect to your IDPs and all of that, so I didn't show that in the picture. But that is the central point where policy decisions are enforced, the policy decisions are made. Enforcement is actually made down on the individual agents themselves. So whether you've got it installed in a cloud, in a instance in the cloud, or you've got a desktop or a user device, the security enforcement is actually on both sides of that connection. So not only are you checking, is that packet able to be received by an application server, is the sender actually allowed to send it? So we'll actually stop it before it goes out of the sending machine. Okay. We do have a gateway model because sometimes, shown here on the right with the services, sometimes you can't avoid that. You just need to have a way to access something that you can't touch. And that's really just for remote access. You can see that there's no way of segmenting that thing. There's no, protection that I can provide as a gateway, for something that's on the same network as me. So I need to access it, then I can use a gateway for it. But if I actually want to protect it, I need a different model, which is down there on the lower right-hand side, which is something that we call microsegmentation gatekeeper. Okay? That is our only hardware product. Everything else is software. But for things like an OT network, you have devices that you cannot install an agent to. You have a legacy operating system, Solaris, or something that's really oddball, OS. There's no way to touch that thing, a mainframe. You want to be able to protect it. We need an security insertion point for it. It has to be outside of that machine, and it has to be as close as possible. So we have that option to deploy that way. And then in terms of connecting everything up here, the application traffic goes through. I'm showing a lot of it going through the center. There's something that we call ZNS, which is our data plane component. You get to decide where you put that. And the important part of that, and why that's critical, is if you have the flexibility to put the data plane wherever you want, then you can have a completely on-prem deployment. You can use MPLS, you can use your existing Direct Connect or whatever, so that the traffic flows that way without having to go out to the Zentera's cloud. We don't want to reroute you through some foreign destination. Keep everything inside that private network where it already is. The application's running well. Don't mess with it. Just add some security layers on top of it. But we also have down at the bottom this thing, CoIP LAN, which is a point-to-point control, point-to-point tunneling system. And so you're able to enforce things like encryption. So TLS 1.3 for legacy traffic, so that I can take all those things, stuff them in a TLS tunnel, so that inside your network, you don't have to worry about people snooping your traffic. Okay. All right. So I will talk about how we would apply this to the SEI RFI, just one slide. So basically, I, like some of the other guys, expect that there will be a pretty complex network that this agency has. Multiple sites that are all connected together by some backbone, with different high-value applications that are in different environments. Some on-prem users, remote users. The mental process for how to deploy Zero Trust using CoIP is that you first start by deploying the infrastructure, and here I showed it deploying into the DMZ of the agency. It doesn't have to be there; it could be somewhere else, but let's assume it's there. Okay. Then onboard all the things that need to be connected. So either deploying agents into the high-value applications. You don't necessarily need to deploy them to things that you're not touching right now. So for example, the other application I'm talking about here, that's outside of scope for the initial deployment, so I'm not going to touch it, leave it alone. For things that maybe I want to segment and control, which I can't deploy an agent to. For example, here, the storage on the right-hand side, maybe I've got some filers that I need to protect because the data is in there, for the database. I can put a microsegmentation gatekeeper in front of it, okay, so that I will be able to protect, those particular assets. Now, if you have data for this project that is commingled together with other stuff, that is a trickier problem, and so I'm not leaving that side outside of scope for today's conversation, but you have to start somewhere. Okay. So once you do that, you can turn on that application chamber to block access from the network, basically cloaking. And then re-enable connections, not only for the remote users, the on-prem users, but anything that you have in the cloud can connect directly to the devices and the applications that they need to. Okay, so that's how it works. Why did I start with that discussion of zero trust and the definition? So hopefully you see that what we do kind of maps well to how I defined it. Those four core pieces with the extension, and also now I want to talk about some of the pitfalls that we've seen when people are trying to evaluate what to do about zero trust. So this confusion leads to lots of pitfalls, and I'll go through some of them so that we can get a sense for what does it mean, what's the impact, how do we avoid it, okay? And basically, if you stay focused on the zero trust definition, I think it's very easy to kind of avoid some of these pitfalls. So start with one, boiling the ocean. So the pitfall here is thinking that zero trust is all or nothing, and the reality is that zero trust is a goal, a strategy that you want to implement, and it takes time to get there. So you can't expect that on day 0 you don't have zero trust, and on day 300 you're going to turn on zero trust, and suddenly the entire agency is protected. It doesn't work that way. You have to get there, and there's a sliding scale of how you get there. So that leads to this thinking of trying to cut corners. How do I trade depth for breadth? And so I know that I can't cover all the different corners, so at least let me do zero trust for one piece of it. I'll cover the remote access, and maybe that'll check the box so that the people will be off my backs. The problem with that is that you will see people doing things like aggressively decommissioning a VPN, which is a good idea. I agree. It's a 26-year-old technology. It needs to die. Okay, but the reality is people are using it for something today. And so unless and until you have moved all your applications into ZTNA, you will either run parallel a VPN and a ZTNA, or you will have a ZTNA that is acting as just a 26-year-old VPN. And so you bought the ZTNA and you programmed it as a VPN for some amount of time until your policies go away. Which that may not be a bad strategy either, but I'm just pointing out that thinking that you're going to just do this and check the box is not necessarily covering all the bases. So I think instead it makes sense to consider an adoption model where you cover an application at a time, and I think M2209 kind of covers that. The recommendation is to start with the FISMA moderate application to get your feet wet, and if you try to go and boil the ocean overnight, you're going to run into some trouble. Okay. Second is ignoring what I call the long tail of access, and what do I mean by that? There is a tendency for everybody to focus on the main application data path for the main number of users, because there are 30,000 users, or in this case, the RFI case, 45,000 users and 15,000 contractors who are all trying to access this thing. So people focus, naturally speaking, on the main application path. So if it's a web application, then it's 443, and it makes sense why people would gravitate toward that. But it ignores that the application, and I'm I'm breaking my definition here. Again, I'm talking here about the web application now, not the actual processes. But the application has lots of critical dependencies, which leave attack surfaces, open for lateral access. So, for example, you've got application database backends. You've got DNS, DHCP, NTP, you name it. Alphabet soup of all these things that need to connect. You've got other systems, performance monitors, ITSM tools, which all need to connect to this application. And so if you focus only on, I've got zero trust on the front end, well, what did you do for the back end? That it needs to be, really thought about upfront and center in the process. So the reality is that, these services can be used just as effectively for exfiltration and for attack. DNS tunneling is one great example where it just is, risky to leave them open. So choose a zero trust approach that allows you to have policies for all of those on day one. Even if those policies are not zero trust policies, at least it is a policy, right? So for example, I could have a policy on day one, which is, I allow DNS traffic. On day two, I change it to, I allow DNS traffic to internal resolvers. It's just RFC 1918 space. On day three, I change it to, I allow DNS traffic to these specific named resolvers. On day four, I change it to, now I only allow encrypted HTTP and TLS DNS traffic. So it allows you to evolve the policy. Once you have a policy, it's easier to change the policy and make it more restrictive than it is to not have a policy. Okay, so that's my second pitfall. Third pitfall is unintended user friction. What I mean by that is focusing on one specific use case, then creating an inconsistent experience. That can lead people to kind of exploring and probing, how do they get around this system? What are some ways that I'm really tired of using a ZTNA? If I plug into the wall, for example, I don't need to use that. I can access the application directly. So this is what I mean by user friction. Now they don't know, am I supposed to always use the ZTNA? Can I get around it in some way? Now, should I do this way or that way? So it creates a cognitive load for users. If you give them one consistent model that's enforced, wherever the application happens to be, wherever that data happens to be, just do it the same way every time, then the users get trained pretty quickly. Okay, and in M2209, there's a recommendation to de-emphasize progressively the user network access. So just don't forget that there's an on-prem piece, and there's lots of ways that people get on-prem access. Okay, so pitfall number 4 is impacting production applications. So there's a tendency to think that, okay, I'm adding zero trust, so everyone has to support this strategy. That means that you application owner, it's okay for you to rewrite some part of what you're doing or change something to be able to support my zero trust data strategy. And that's not true. So the reality is that the vendors who made that application, or the DevOps people, or the network teams may not have the bandwidth or the time to care about your project, right? So if you are dependent on them for the implementation of your zero trust security, then you're hostage to whenever they get around to it. Right, so things that work or worked before suddenly break. You have to redo compliance because now somebody has touched the application in some way. So lots of examples. If you are using a network segmentation model that requires re-IP of an application, you're asking for trouble because something will break and the user will not be able to access it, and there will be some time when things are kind of broken before they get better again. Okay. So just a couple examples here. I'm not going to go through all of them, if you change the application behavior significantly, you have to be ready to deal with the consequences, and that's why we think it's important to figure out ways to implement zero trust without breaking the application or touching it as much as possible. Fifth one is cementing new infrastructure dependencies into security, and when I first version of this presentation, I called it enshrining, but cementing is also, I think, a good word. So thinking that if you have to use network security to get your job done, creates a challenge that now you're dependent on that network security. If I go to another environment or I need to upgrade that security later, I've got lock-in. I'm dependent on somebody to have done their job the right way so that my security can be implemented. So that makes it really hard if you have to change the technology stack, if you have to move from one environment, from one cloud to another, if you have to change the security policies as applications move, you have to go send a ticket to some other team so that they can support you, and it just makes things really hard. So this is kind of why we have that vision again of really decoupling networks and security, because we don't want to get step into that. The way to avoid that is to follow that as much as possible. Really try to avoid dependency on network teams to get your job done. So if you do things well in Zero Trust, I believe and I contend that it's actually an enabler for infrastructure innovation. So if I can do Zero Trust security well in my on-prem environment, and I have those same controls, I can take them to any cloud and know that my same controls are in place, then that means that I can move to that cloud much more quickly than if I have to depend on somebody else to figure out how to program that cloud so that it does what I want. Okay. The last one for today is focusing on Zero Trust from the outside in model. What I mean by outside in is that there's a tendency in security to focus on the users for good reason, because users always get us in trouble. They're the ones who click on phishing links. They're the ones who introduce all these problems in the first place. So we want to lock them down. We want to protect them. But really what we care about at the end of the day is not the user. It's the applications and the data. You don't get on news because somebody got phished, right? You got on the news because somebody got phished, and then that pivoted laterally internally to an exfiltration, and your database is on the dark web, right? That is why you're on the news. So there's so many other ways in. I apologize for the typos there, but you get the point. USB drives, sneaker net, supply chain attacks, you name it. There's just so many other ways that somebody can get into the enterprise. So if you spend your whole Zero Trust budget with upgraded user security, you're missing the point. Okay, so where I see that people going off the rails here is that they start to prioritize things that protect the users. Not that these are bad; these are important, and there are some EDR vendors that are better than others. And I'm not here to I don't have a dog in that fight. But my point is that if your response is always to go do the same thing, you're going to run into trouble because you're not actually protecting what matters. And this gets to, I guess it's Chase or John's, maybe it's John's slide, the beast, right? The picture yesterday of the president and security. You don't start by figuring out how am I going to filter all the people who might get to the president who are around. You start with where is the environment that the president is in? How do you harden that thing as much as possible? And then you start to define policies about, okay, well, if I need to get a message or something to him, how would I do that? Does he roll down the window? I don't know, actually. I have no idea what you do in that kind of case. But you have to have a policy, right? And so if you think about it that way, then the high value asset is what you want to focus most of your time in. Starting inside out, first answer that question: how do I protect that asset, that database, that data? What do I need to do to protect it? And then decide, how are you going to provide access to it? Is that a secure way to do it? If this is my company IP, it's my source code, do I want to only provide VDI access so that people can't copy things out of it, and so that depending on what that target or that access or application is, the access method will make sense for that. So rather than deciding on the access method and then trying to apply it to everything, choose it appropriate for whatever that application is. Okay, and so I think that's pretty much it. I don't know how we're doing on time. Yeah. So last point, I guess, if you keep the definition in mind, at least mine, hope, it helps me when I think about different assets and different features and different things that we can put into our products to help customers, I use that as the way that we kind of figure out, are we doing our job correctly? And then, to succeed with Zero Trust, you just be clear about what you want to achieve, consider how do I avoid these pitfalls, focus on things that really matter. And then I would say, bite the bullet and start developing policies, because at the end of the day, we are going to move to a environment or a future where there are policies for everything. Part of the problem and the pain is that the policies don't exist. The policies are all topology based. You have to be on the network, or you have to be in the right place before you can get this access or do that thing. So we are creating that policy structure, and regardless of who you choose, it's a lot easier to move and to be quick and move from one solution to another if you have a policy versus not having a policy at all and trying to figure out what to do. So I think that the sooner that you can move to starting developing policies, the better off you'll be in the long run. So that's it. And,
Thank you, Mike. Currently, we don't have any questions online. Does everybody like to ask Mike a question?
I got a question.
yeah.
Can you provide some more context around your guys' hardware offering?
Hardware offering, so I can provide some more information, but high level, we have a gatekeeper. Okay, the gatekeeper is an inline bypass. We have different models with gigabit Ethernet all the way up to 40, 100 gig. And so the concept is that you want to put that appliance as close as possible in line with the thing that you're protecting, so that it is enforcing a zero trust perimeter at that point. So OT networks, or a database server or something like that, where you just can't touch the asset. That's where that makes sense.
What's your specific context or type of system that you'd say you guys use it for most? What's the predominant use case?
The biggest use case now is OT. Yeah,
okay.
Yeah, for sure. Because you've got a lot of things in the OT environment that need protection. There's a lot of flat networks in OT, and you need some way of inserting security, and a VLAN firewall mess. I think somebody called it a VLAN soup yesterday. That's just not scalable.
Appreciate it.
Yeah, and it's not zero trust either. So.
Policies, I'm interested in you sound like you're talking about Word documents. How do you guys deal with that? It starts with that, and then you get it down to the level where you can use it with that.
It's a good question. You do need to start somewhere. We have policies that are expressed in our database today. I think it's an active area. Maybe you're going to ask me about, how do you, deal with that going forward, or what are the areas that we need more research in? I think maybe more standardization. And I'm going to preface that question by saying that things that like XACML, are interesting, but they're also really old. So I don't know that that's the right way to do it, but there has to be some good way of doing it. So right now we have our own specific policy, definition, which is kind of core to us, but it is likely to be very portable because their attributes and their users and resources. So some combination of that is likely to be easily standardizable among different vendors.
You don't talk much about the data itself, and that to me is, I'd say I've seen that repeatedly, is that's a gap in a lot of coverage areas. Like DLP is the antichrist of security, right? Everybody hates DLP. So the question that I kind of see is, architecturally, how you're doing what you're doing, proxy brokers and all that make a lot of sense. The policy model, that's great in there.
Yep.
But at the end of the day, the Alamo is the data side of this equation. How do you apply controls to the data itself specifically, especially government systems? We're talking about structured data being the crown jewel. Why is that not part of the overall approach? Or is it just, if you do all these other things, the data is secure because the data is secure?
No, I don't think that's the case. I think that most of our engagements have been on the enterprise side. The data is always a difficult problem. I think a lot of people who are outside of government don't have, well-structured data. They have it all kind of put together in an R&D zone or on some spilers for this purpose or that purpose. So I think there is benefit to having knowledge and structure of the tagging of data and being able to apply that policies based on that. That said, what we have done so far is rather than focus on the data itself, is try to create zones where that data can be handled and in a secure way. So for example, intellectual property, that say it's source code for some product, right? If you can create a zone where that can be checked in, checked out, and then users can access that thing, they can never exfiltrate data out of that to their laptop, so it stays in that zone, then I didn't necessarily need to tag it, but I at least know where it is, and I can keep it in the same place. So as you get more complex, I do think that there's a lot of benefit to doing things with tagging, though. So, I mean, we have done other things, like, for example, we have a feature in our latest release where, based on the user role, privilege, and policy, you can automatically mount certain files or certain directories for them, which is another step toward that. But I think that there's still a lot of ways to go for data. Yep.
Well, thank you, Mike. Appreciate that. That was very good.
Thank you.